In the previous part, we learned about what is a GPT and what is a transformer and a token. In this part, we are going to explore why are GPT models so powerful. Additionally, we are going to learn about what does it mean for the consumers using these GPT models. But we will touch base into what is prompt engineering, but it's not an elaborate section. We are going to cover in a later section on broader understanding about prompt engineering, but we are going to help you understand why is it so important. And we are going to finish off this particular part by discussing into what could be the potential of GPTs or GPT model in the future. Enjoy.
So, what does this all mean? So, what this is really allowing us to do is take these models and use them in so many different ways to generate new content. But it goes much more beyond that. We often see these models used in a chat scenario. We have an internal saying that we often share, which is ABC, which is AI beyond chat, because these models have the ability to do things like reasoning. They have we can ask them to select whether A or B would be the best option based on a series of inputs. We can ask them to help us solve logic problems. All of these are things we're able to do with these models, and beyond going just being able to interact with a model in a chat scenario. So what's really exciting is how we are going to be using these in this future of this era of AI. So again, what does this all mean for us as people using or consuming these models rather than training them? It is limitless generation. So you can put a few lines of input into the prompt, and prompting is a skill we all need to develop as part of this. We can put a few lines of input, and we can generate logical. We can ask the model for guidance, logic. We can ask it for reasoning. We can provide large amounts of input data. For example, we might put our entire HR documentation into a prompt and say, now tell me what is the best, you know, how much leave should I get every year? We can
Hmm.
ask all those questions. That's what we would often call RAG, or retrieval augmented generation, which we'll save for a topic for next time. Um, we also, again, it's pre-trained. They are large foundational models. We are seeing the development of SLMs now as well, which are small language models. And again, we have termed these large language models, but some of these models are what we call multimodal. So they go beyond language. They can take image, they can take audio. And if you look at a model like GPT-4o, the most recent model from OpenAI, that model can take an image and text, and produce image and text. Right now, it's only text output, but the model is trained on image or speech and video, and will be able to generate those as well. That is what we call a multimodal model. So, although we term these LLMs large language models, they do more than just language. Uh, and the reason why they're able to do more than just language is because everything they do is based on tokens. An image can be represented by a token, by broken down into tokens. And we could go right down into a rabbit hole on that as well. Um, Again, not just chat. We've seen chat as a great platform and use case for this, really enabling natural language and interactive and ways of interacting with systems that are more natural to us as humans. Um, but we're seeing so many non-interactive use cases, being able to take actions, being able to understand and reason and provide summarization behind the scenes, some really powerful things. And finally, it requires a new semantic approach. It requires us to rethink how we build software and deliver features. And prompt engineering is now becoming a technique that all engineers and non-engineers need to be aware of and understand. It sounds technical, but it is as simple as being able to explain to an AI in a very clear way what we want it to do.
Right. So, quick question, Daniel. So, I know that prompt engineering is very important at the moment, but do you see in the future where not so clear prompting could also can get us good results because the model will learn, have gain ability to figure out these are not rightly asked, but it can give much better responses.
That's a really good question, because the models are already pretty good at sort of, you give it a spelling error, maybe
Yeah.
your grammar's not very good, or it's not particularly clear, and the model will do a good job of it. Where prompt engineering comes in is less about how you write something. It is more a number of techniques around how do we. So these models have no idea or understanding around the context. They are what we call a stateless model. When
Yeah.
you send something to the model, it processes your input, gives you an output, and forgets everything. There is no memory,
Mm.
there is no storage. It is a new every time you interact with the model, it's a new round of interaction. It's never spoken to you before, seen anything from you before.
Right.
Because of that, we have to provide the context of what we
Mm.
are talking about every time we interact with it.
Mm.
So this is where the concept of grounding and comes in, which is putting the relevant information into the prompt that the model needs to know to answer the question. Because if we were to say, right, I'm doing my taxes, and what do I need to do? The model isn't going to know that I'm in New Zealand and that I need to deal with New Zealand tax law and tax codes and all that
Mm.
stuff. It's going to give me US tax stuff, because probably that's the biggest amount of data it was trained on.
Yeah.
And if I don't tell it, I it's not going to know. And if I don't tell it to not do certain things, it will maybe answer in a way I don't want it to answer. So all of
Mm.
these are prompt engineering techniques. We also often want to give the model an example of how I want it to answer. Because if I don't tell it, I would like this as a table, or I would like this as JSON, or I would like this as something else. If I don't tell the model, it won't know. And so all of these are considered prompt engineering. Everything we're doing is trying to instruct the model as clearly as possible
Right.
to give us the output that it wants,
Right.
that we want. Apologies.
Yeah. Maybe in the future there'll be models which you constantly interact, keep a track of your behavior, your question, understand more about you more and more, so you eventually end up asking, giving less context, and it kind of understand the concept. Do you think that is going to be
It's it's a great
the
question. I
future?
don't think we'll. So what we will see. So the models themselves, as I mentioned, we don't want to train a
Mm,
model with knowledge about me, right? Because that would mean that knowledge was available to someone else. So these models are never trained. They're not usually trained on the interactions that users have with them, because that
mm,
that wouldn't necessarily be a good idea. And again, the cost of training a model, very,
right.
very expensive. So we don't do that. What we do, however, and we see this, in fact, you can do this now, we have this concept of memories,
Mm,
where when I'm interacting with a large language model, I might have a behind the scenes prompt that says, hey, Dan said he really likes DevOps books or books on science fiction. I might ask the model, say, Dan said this, which of these things that he said might be worth remembering for a later conversation? Now, if I'm a
mm,
bookstore, perhaps I'm selling books online, my AI might go, well, you're a bookstore. It's really worth remembering that he likes sci-fi and DevOps.
mm,
And you would store that in a traditional way. You don't need an LLM for that.
mm,
You don't store it in the LLM. And then next time I ask the LLM, hey, look, I'm looking for a new book, the prompt that goes to the large language model will say, you are talking to Dan. He really likes DevOps and science fiction, because that's
mm,
pulled out of the memory store. And that memory
mm,
store is just a normal database, nothing fancy, no AI there.
right.
And the model is told or grounded with the knowledge or the memories of a previous conversation.
Awesome.
So that
Yeah.
that's how we could do it. Or if it was in a single conversation, we had a conversation with the model, we'd been back and forth for the last 5 minutes over books. What's actually happening behind the scenes is every time I provide another round of the conversation, or I make another comment or ask another question, the model is actually the interface, the user experience is actually taking all of our previous conversation along with what I've just said and sending that back to the model and saying, now here's a conversation. what are you going to answer with? So that's how memories are stored within or provided within a conversation, but it's the
Mm,
memories provided outside of a conversation. But it's important to remember it's not, a model is never going to be trained, or very unlikely to be trained with your interaction. Simply, it doesn't, it would be a bad practice from a security perspective. It would be very expensive, and
mm.
right now prohibitive. And usually there are better methods. In fact, there is always better methods, as we said. Store it using a traditional means, inject it back into the prompt.
Yeah,
Does that make
got it.
sense?
Yep, perfect. Thank you so much.
And one other point I'll make is that, as I mentioned, these models are trained on a point in time, and they aren't actually connected to the internet. So if you
Mm,
were to ask them about current news affairs, they don't actually have an answer.
mm,
And if you go to somewhere like copilot.microsoft.com and say, what's the latest news on, you know, the cricket tour for West Indies,
mm,
um, it is going to go, well, actually, I don't know. I was trained 6 months ago or a year ago, and there was no tour in West Indies that time.
mm,
But um, what we will often see is a process where we are grounding the prompt on some information that was looked up on the internet. Now, the model didn't do that. Our orchestrator, and again, another concept we should talk about in the future is how do you build a copilot or an orchestrator, an AI orchestrator that is able to go off and retrieve information from the internet or your internal sources or a database or your memory store. These are all what we call memory generation or memory retrieval processes. How do we do that? So it's really important to remember the models don't have access to the internet. They don't have access to your internal systems. They don't have access to anything else. If you want them to be able to reason over the data you provide them, that is your job as an engineer to build all of that. And that is fundamentally prompt engineering, is how do we get the relevant data for the
mm.
model to use in its answer to us, um, if it doesn't have access to this. And there's many tools and many solutions out there that will help do all this work and make it easier. And that's definitely something we can cover.